Okay, so here we're faced with a problem that wants us to expand x plus 3, that quantity, to the fourth power. Now, this wouldn't be terrible to write out x plus 3 times x plus 3 times x plus 3 times x plus 3 and go through that multiplication. It's doable. It'd be much more doable than if that was an 11th power or something like that. But either way, let's take a look at the binomial theorem and how we can use that in conjunction with Pascal's triangle to go ahead and expand this in a different manner. So the first thing I see is I'm taking this to the fourth power. So I need to go to the n equals 4 row of Pascal's triangle, which I had created for you in a different video and showed you how to create that for yourself. So the n equals 4 row of Pascal's triangle has numbers 1, 4, 6, 4, and 1. So I'm going to go ahead and list those. Again, starting from the top down, that's the fifth row because the first row is the 0 row. So 0, 1, 2, 3, 4, 1, 4, 6, 4, 1 are my coefficients from Pascal's triangle. Now what I'm going to do is I'm going to take the two pieces of the binomial. There's an x and there's a positive 3. And I'm going to write those after each one of these coefficients in parentheses. So I'm going to put an x in parentheses after each one. And then I'm going to put a positive 3 in parentheses after each one. Those are the two pieces of this binomial. Now, I'm going to go ahead and fill in powers on this, starting with the x's, starting at the power that I see in here and just going down the line. So I go 4, 3, 2, 1, and 0. And then with the 3's, the second piece, I'm just going to go right back up the line the other way. 4, 3, 2, 1, 0. Again, the exponents that I'm putting on these two pieces should always total this exponent out here that I originally had. 4 and 0 is 4, 3 and 1 is 4, 2 and 2, 1 and 3, and 0 and 4. Now it's just a matter of evaluating each one of these pieces. Anything to the 0 power is equal to 1. Multiplying by 1 doesn't do anything to the value of any of the term, so I'm just going to go ahead and cross that off and not worry about it. So here for this first term, I'm left with x to the fourth, which is just x to the fourth, then times 1. So the first term of this expansion is just x to the fourth. Now here, I have 3 to the first, which is 3, times this 4 out here, which would make 12. And then here I have x to the third, which is just x to the third. So there's my second term, 12x to the third. Down here, 3 to the second, 3 times 3 is 9, times 6 is 54. So I have 54, and then x squared for that. Down here I have 27, 3 to the third is 27. 27 times 4 is 108. I have 108, and then x to the first. And then finally, this term is gone right here. It's just 1, so I don't need to worry about that. 3 to the fourth is 81, times this 1 is just 81. So now I have the terms of this binomial expansion. I just need to go ahead and write them out. This would be x to the fourth power plus 12x to the third power plus 54x squared plus 108x plus 81. So that is the expansion to that. Would be the same thing that I would have got if I wrote out x plus 3 times x plus 3 times x plus 3 times x plus 3 and started doing that distributing. As you would start to see, that would become a lot of work, and there's a whole lot of distributing and lots of like terms to combine and all that. This is just a different process to do so that is a little bit quicker and a little bit more efficient as long as you understand how I'm setting it up and how I'm simplifying it. So that's an example of that. We'll look at several other examples here in a moment where different things about this change and maybe get a little bit more complicated, like what happens when there's a negative here. What happens when there's a number in front of this? What happens if there's numbers and variables in both places? What happens if there's a power on the variable inside there already? How is that affected? So we'll look at that in